Hi everybody, it's Mr. Zabo. This video is going to talk about solving absolute value inequalities and graphing them. In the previous video we did absolute value equations. This process is similar, but with the inequality symbols there are a few key distinctions that we have to make. Plus, when we graph this, we do have to shade, unlike with absolute value equations. First key piece of information is recognizing when we have an AND inequality and when we have an OR inequality. Because remember, these are always going to be compound inequalities. And it all has to do with the sign. In this case, we're dealing with a less than sign. And anytime we have a less than sign or a less than or equal to sign, those are going to be AND inequalities. And then on the other side, a greater than or equal to, and that's going to be an OR inequality. And that's for greater than or equal to, or just greater than. So, with AND inequalities, and that's again absolute value less than, is an AND inequality, and compound inequality. What we want to do is we want to take the entire expression that's inside the absolute value, write that down, that becomes the middle part of our compound inequality. Since this is less than positive 18, that stays here. Don't need the or equal to, get rid of that. But it's also going to be greater than negative 18. So I'm taking the positive, has to be less than, and the negative is my expression's greater than. So now when I'm solving this, we've done videos on solving compound inequalities, I have to isolate my variable inside my inequality symbols. I'm going to add 5 on both endpoint restrictions here. And negative 18 plus 5 is going to give me negative 13. 18 plus 5 is going to give me positive 23. I've isolated x. My symbols don't change. That's my solution. If I were to ask you to write that in interval notation, we would have written that as negative 13 comma 23 with parentheses on both. And then graphing, I have 0. I have my negative 13, I have my positive 23. These are both non-inclusive, so I have open circles, and it is greater than negative 13, so I'm right of negative 13. It's less than 23, I am less than 23, I'm to the left. There's my solution. For the second example here, there's a slight difference. I can't just take my x plus 1 right away because I have this negative 2 in front. So I do have to isolate, just like with absolute value equations, isolate that absolute value, which means in this case, divide both sides by 2. Absolute value of x plus 1 is greater than or equal to 7. Now I can take this absolute value, which is a greater than, so I have an OR inequality, and I'm going to take my x plus 1 is greater than or equal to 7, so my absolute, what's inside my absolute value greater than this number, or the x plus 1 is going to be less than or equal to the opposite. And again, this goes back to distance from 0. I could have a positive or a negative, because I could be in the positive direction or negative direction away from 0. And then solving. X plus 1, I'll subtract 1 from both sides. I get x is greater than or equal to 6. I need the word OR. Subtract 1, x is less than or equal to negative 8. There is my solution. If I were to ask you to do that in interval notation, sometimes OR equations are easier to do that in after graphing. Less than or equal to negative 8, I'm going to have negative 8, greater than or equal to 6, positive 6. Careful with the graphing. A lot of times people mix this up because the negative or the positive 6 is over here. They just put my 6 here. And be very careful knowing your number line. close circle, 0 is not a solution, graph away from 0, close circle, 0 is not a solution, I graph away from 0. Now that might help us with our interval notation, recognizing that this is negative infinity to negative 8. Okay. Negative infinity, we always have parentheses with our infinities. Bracket at negative 8 because it's inclusive. Or a bracket for positive 6 goes all the way to positive infinity and a parentheses.